will begin. Good evening, everybody. Thank you so much for coming out tonight. My name is Alec Romero. I am the Director of External Affairs at Unitil, and we're here to talk about some important infrastructure projects that we have going on here for the town of Lunenburg. There was a little bit of electric infrastructure news here in Massachusetts just last week as the Massachusetts Department of Public Utilities released what their order on the electric sector modernization plans for all 3 electric utilities in the state. What those plans are is each utility went through and outlined the types of projects that they believe would be needed for their communities in order to support all of the electrification efforts that are expected as part of a clean energy transition. That includes things like the adoption of electric vehicles, the adoption of electric heat. And our plan tried to outline everything that we believe were going to be needed for our 4 communities. And that did include these substation projects that we're talking about here today. These substation projects have the benefit of not only supporting that growth, but also supporting economic growth in town, as well as safety and reliability. So here today to talk about those projects is Jake Dusling, our Director of Electric Engineering, who has been instrumental in designing these projects. They're still in the early design stages. He's going to talk about what they are, why we need them, and why they will benefit folks here in town. And once we get all the way through that, we will have some time for questions, if anyone has those. If anyone has needs of translation, we do have translation services in the back for both Spanish and Brazilian dialect Portuguese, which are the 2 languages that are most commonly spoken aside from English within our service territory. So those are available, and we do have translated information sheets available out front, as well as on our website, unitil.com. And with that, I will hand it over to Jake.
Thanks, Alec, and welcome. So, like Alex said, we're going to talk about 2 specific substation projects here today, but we're going to start with more generalities around the electric system and stuff like that. So we're going to start off with a safety minute. Safety is very important for Unitil. We like to start all our presentations and meetings with a quick safety minute. So in this case, we're just going to talk about slips, trips, and falls. We want to try to avoid those at all costs, so be present where your feet are, watch for obstructions, avoid wet, slippery floors, that type of thing. Just be careful where you're walking. Try not to look at your phone too much. Pay attention where you're going. So the agenda today. Like I said, we're going to start off with a quick discussion about what substations are. That's going to start with what is generation, what's transmission, what's distribution, what role does a substation play in the electric system. Then we're going to get into those specific projects a little bit. We're going to talk about the existing Lunenburg substation that's off of Massachusetts Avenue. We're going to talk about the planned expansion for that substation, as well as a new substation that's proposed in the southern part of the town. So what are substations? There we're going to start with what is the electric system. Your basic electric system starts with generating plants. That voltage current then gets stepped up to the transmission system to be transported to the towns, step back down to feed the local roads and houses. Traditionally, it flows from the generating plant through the transmission system to the distribution system. Over the last decade, we've seen this changing. And it's changed a lot here in Massachusetts and in Lunenburg, where we're seeing a lot of homes, customers having their own generation. That's turned all this into a 2-way street. Those homes are feeding into the distribution system, back into the sub-transmission system. Those electrons flow throughout the system and feed where they need to go. So these projects help support that as well. So a little bit about each one of those components. The transmission system or sub-transmission system are typically those high voltage lines that you see running through right-of-ways, through towns, through the state. They use that high voltage to be able to transmit power over very long distances. That high voltage allows for less voltage drop, less losses. It's more efficient to transmit large amount of power that way. to relate those to, we'll use a roadway type of system. Those are more like your interstates, your high-speed highways, those type of things. Those lines in our area are typically 69,000 volts or 115,000 volts. Those lines then end traditionally at substations. Substations are like your interchanges of a highway, going from one highway to another highway or a highway to local road systems. It changes voltage from one voltage to another voltage, allows it from a local road standpoint to get down to voltages that we can safely distribute amongst the town that can then be stepped down to feed local homes. In this case, we're talking about substations that's taking transmission voltages down to local street level distribution voltages, same voltages you see out on the street here. And then they feed into the distribution circuits, which is that medium voltage, usually 13,000 volts or 4,000 volts. And it's, like I said, it's utilized to distribute power around the neighborhood. Those are like your local roadways that are out here and stuff like that. And if you were to take that one step further, your driveways are like your services, right? Your 120, 240 volt, the lines that feed into your house to allow you to utilize that power and feed everything in your home. Substations themselves. The location of substations is very important. A lot goes into locating those and placing them in the correct location. They're typically located in the vicinity of those transmission lines. If they aren't, it requires extending those transmission lines to the substations themselves. They also need to be placed locally for the area they're going to serve. Right? So by placing a substation in an area that doesn't need that capacity, it doesn't really benefit the system in the same way as placing it where that capacity is needed. And then another big component there is it requires a decent sized area of flat, dry land to be able to locate the substation. The nature of this equipment doesn't allow it to be on slope surfaces and those type of things. When Unitil designs a substation, it has to comply with the National Electric Safety Code. That is the code that governs, in Massachusetts and most of New England and most of the country, design parameters around utility infrastructure. In most cases, substations look kind of similar to what's in that photo right there. Steel structures, concrete foundations that support those structures. The structures themselves support a lot of the electrical equipment that is there. They all have a fenced area to prevent unauthorized entry, keep the public, non-workers safe and out of those areas, also keeps larger animals out of those areas. They're typically flat, surfaced with crushed stone on the ground. That crushed stone is a very important component in substations. It is primarily there for the safety of the individuals entering and accessing and being around the substation. And from a physical size of a substation, it needs to house all the equipment, maintain all our necessary clearances, but also provide the necessary space for worker safety and emergency equipment. If something were to fail in those substations, we need enough room to get the equipment in there to replace that, put emergency equipment in place, and so forth. Additionally, the design of a substation has a lot of redundancy built in, especially new substations. In most cases, we can fail any one piece of equipment, sometimes two in a substation, and get everybody back on in a very quick manner of time. So we'll talk about the Lunenburg projects now in a little bit more detail. So this is the existing Lunenburg area. We currently have one substation that feeds the majority of the town. It is located off of Massachusetts Avenue, pretty much right at the intersection of Massachusetts Avenue and Leominster Road. It's set back quite a bit off the road, not all that visible from either roadway. That substation itself has one power transformer and two outgoing distribution feeds out into the town. If you look at that map there on the right, you can see the town lines in black, kind of on the outside edge. There are two, the footprint of those two circuits. The one shown in blue there kind of feeds a majority of the northern portion of town, and that pink one feeds the majority of the southern portion of town. It's currently supplied at a sub-transmission voltage of 69,000 volts from a transmission supply in the town of Fitchburg, or the city of Fitchburg. That's located in, I call it the southwest corner of the city. We have seen approximately 2 megawatts of load increase at this substation in the town of Lunenburg over the last 5 years. We expect that to continue, mostly due to electrification loads. There's also some commercial industrial load kind of in the infancy stages down in the southern portion of the town. So we do expect that to continue. And additionally, over the last 15 or so years, we've seen a great increase in that PV solar generation in the town. We're up to almost 6.5 megawatts of solar connected to this one substation here. That is almost, it's approaching the amount of normal load served by the substation. So this substation does see power flow from the distribution system to the sub-transmission system during the spring and fall. So to help address the increasing amount of solar generation, as well as the increasing load, we're proposing to expand that substation. That substation, the expansion plans right now, we're going to add a second transformer, which provides some redundancy. 2 additional circuits, so for a total of 4. And then we will reconfigure those 2 circuits into what you see there in the map in the middle. So the 2 to the north we're going to split in 2, and the 2 to the south we'll split in 2, to kind of better distribute customers throughout those circuits. That'll provide a lot of redundancy in the town, a lot of automatic restoration capability potentially, and definitely a lot of manual switching capability if there's a major impact to one of these main distribution feeds that come out of that substation. It'll provide switching capability to switch around that and shorten outages quite a bit. At this stage, it's in the preliminary design material specification stage. As Alex said, the ESMP was just approved. That gives us some guidance on where that design needs to head. The goal is to start construction of that project sometime in the middle of next year. Probably right around now, a year from now, with an in-service date of probably around June of 2026. Right now, the estimated cost of that expansion is about $9.1 million. And in the end, it should alleviate the loading constraints associated with the existing substation, increase the amount of solar that can be connected in the town, and like I said, it should improve the reliability throughout the town. The next project we'll talk about is South Lunenburg Substation. We're kind of calling it that at this point. It's really a substation that's proposed in the southeastern portion of the town. So the plan there right now is to construct a brand new substation in the southeastern portions of Lunenburg. That will be supplied off a new transmission supply into the town. So there's currently, in that red wing that you see there in that lower right map, there's a current national grid transmission corridor that runs through that small portion of the southeastern portion of town. This substation would plug into that transmission corridor and then feed a good portion of the town. The new substation will have full redundancy in all components. 2 transformers, 3 to 4 circuits with the possibility of 6 down the road, depending on what we see for growth in that area. Again, we'll reconfigure all the circuits in town. So you can see it changes quite a bit again with those, total of 6, 7 circuits feeding the town, opposed to just a majority that's fed from 2 today. It does provide us that second supply point off the transmission system, so this substation itself is fully redundant from anything else we have in our system. So even if we were to lose that supply in southeast Fitchburg. This substation would remain going, have the capacity to restore a good portion of the town, most of all the load that's fed from the current substation. So it provides quite a bit of redundancy there. At this point, we're just in the preliminary land investigation stage. We're looking for where this might be sited, what might be available for land in this area, where we could physically put it. We're also in the preliminary discussions with National Grid on what it would take to plug into those lines. So it's very much more in its infancy than the Lunenburg expansion project. But right now we're hopeful construction may begin as early as the third quarter of 2027. It's a much larger project, a much lengthier project. It's going to take about 2 years to complete, which would put it in service about 2029. And this one has an estimated cost of just over $20 million.
So, quick questions. What's the value of doing that versus just expanding the current one to say 3 transformers with additional switches? Why would you?
Can you say that again? Sorry.
So, what would be the value of doing a second substation versus expanding the first one to say you have 3 transformers instead of just 2?
So part of it is how far that power needs to flow, right? So if you looked at that other map, the first one's in essentially the northwest corner of town, and then you have the other one in the southeast corner of town. So when we're talking about transmitting power all the way from that northwest corner all the way down, the amount of voltage drop and other infrastructure that would be required on the street to get there isn't, I don't want to say feasible, but it's not as advantageous as a new substation. So at this point, our next steps is, we're working on the preliminary designs of these stations. We're trying to determine ultimately the equipment that's going to go there, the physical size that these will need to be, and ultimately get to that final stage of where we're coming to the town with, this is what we're looking to build in detail. So with the Lunenburg expansion, we expect to complete the preliminary design sometime in the next 3 to 6 months, hopefully by the end of the year, and then start that construction permitting process. At that point, we would be submitting applications to the town, going through that formal town as well as potentially state permitting effort, depending on what's required. And then, like I said, construction will begin about this time next year, in service in 2026. South Lunenburg is definitely going to take a little bit longer. We're hoping to have the land, the physical location of that substation identified by the end of this year, which will allow the detailed preliminary design to take place, detailed discussions with National Grid, that transmission provider, and then by late 25, we'll be starting with that permitting effort, possibly early 2026. And then construction will begin sometime in 27 and in service in 2029. So at a high level, those are the 2 projects we're talking about. Any questions associated with those? Or, in the greater service, how do we configure those circuits or anything like that?
In terms of the adding redundancy, what's the current fail rate in terms of how often are we seeing failures? I'm relatively new to the town, so.
Yeah, so it depends on what type of equipment you're talking about. When we're talking about substation equipment, it's fairly rare. The exact number I don't have off the top of my head, but a substation power transformer failure is, it's probably a 1 in a 5-year type of event. And that's system-wide, that's not a particular substation. It becomes other challenges with those do get taken out of service on a regular basis for maintenance and other things. I think the bigger reliability benefit here is the multiple circuits out on the street. So when you're talking faults on the street from like a tree branch coming down or something like that, those are far more common. You could have a couple of those, maybe more a year. So these additional circuits also give, the substations give the capacity to be able to do it. The circuits give the on-street infrastructure to allow those circuits to reconfigure or to allow our system operators to reconfigure them.
Thank you.
Well, thank you, Jake. Appreciate it. I do want to add for anybody that's watching at home, as well as the folks here, we have special landing pages on our website, unitil.com, that have additional information about these substation projects. Much of the information you actually just heard this evening. We do have translated information as that as well. We also have information about the electric sector modernization plan, and more importantly, we have fields on both of those landing pages for people to be able to offer feedback. You can send those in. We have an inbox set up, so if you have any questions, you can write it in there. We'll send them, and I personally responded to a couple questions that have come through that field, so please don't hesitate to use them. With that, we are going to conclude this presentation. We are doing a virtual presentation again tomorrow. And really thank everyone for coming out today. It's good to be able to share information about what's going on in terms of electric infrastructure. So thank you for listening.